Welcome to our topic of the day. Today, this is basically Form 4, and I'm going to handle turning points. Okay, you are given an equation, you are asked to determine the turning points. That one, you give the coordinates of the turning points. But if we are asked to distinguish, then we have to say whether it is a minimum or maximum. Okay, now basic, at any turning point dy dx is 0. So look at this example. We are given this equation and then we are asked to determine the turning points. Okay, so I've written at turning points dy dx is equal to 0. So we differentiate this, and the differentiation process is in the table. Okay, so you can't make mistake there. This becomes 3x squared, bring down the power 16x, reduce the power by 1, and here plus 5 is equal to 0. So we are trying to get the turning points, specifically the x coordinate. So we solve this quadratic. The PQ gives me 15, and then P plus Q negative. PQ gives me 15, okay, and then P plus Q gives me negative 16. Always get those factors from product, not sum. Sum takes you long. I'll show you one day. So negative 15 and negative 1x, negative 15x, negative 1x is the sum. I've written in blue. You see how we replace the middle term. Okay, but when you multiply these two, you get positive 15. So go through the process. Form 1, factorization by grouping. I group these two, factorize 3x. I group this, factorize. I will show you how to handle this one day. Simple. Come here. X minus 5 in bracket 3x minus 1 is equal to 0, meaning that x is 5 and x is a third. Those are x coordinates where there is turning point. Those are x coordinates. If I wanted y coordinate, I just put x one at a time. Okay, take x, put it in the mother question. So I take x, put it here, cube it, minus 8 bracket 5 square plus 5 bracket 5. If you do that, you get the y coordinate, which goes with 5. Similarly, you do for a third, but that's for another day. So we want to distinguish today. So at x is 5 and at x is a third, at these values, okay, the dy dx is 0. You can see I've written here dy dx. Now let us focus a bit down here. Sorry, just focus a bit down here. Okay, at x is 5, dy dx is 0. At x is a third, dy dx is 0, because of these values we got. Okay, the dy dx is here. This is our dy dx here. So this is very important section that you will have to get again to. Okay, now what you do, take a number one step below, one step up. Okay, it should not be very far, just close to this in red. Like now here I've taken 1, easy substitution. I've taken on the lower side 0, very easy substitution. Here I've taken 6 on the upper side, 4 on the lower side. These ones, when you put in dy dx here, you should know whether it is positive or negative. You don't need to compute and get us the exact answer. You only tell us negative or positive. 4 squared, 16 by 3, 48. 48 and 5, that is 49. Okay? Compute this. 16 by 4, 64. So 49 minus 64, it is a negative number. If this is well done, then this automatically is positive. You don't need to do again and again. No, do one part well, you get the opposite. Come here. Substitution by 0 is very simple. 0. Here, this disappears. 0, it disappears. Okay? Can you see that? Here, 0. 3 times 0 minus 16 times 0, you are remaining with only 5. Is a positive. So if that is well done, if this is well done, automatically this becomes negative. We rarely handle points of inflection. Okay? We have to be reading the exam ahead. This and that. You don't need to repeat. Do one properly, get the other. So what do I do here? What is the nature of this gradient? This is basically gradients. A horizontal line, its gradient is 0. A gradient, a line whose gradient is negative in nature is like that. And the one which is positive is like that. And so on. So you find this is basically this kind of structure. And this is basically a cup upside down. Okay? So at x is equal to 5. You see, our x was 5. And this is the structure. This is the curve, the nature. We say that is maximum. And when it goes like this, it is minimum. Remember, if you are asked the y coordinates, then you put x in the original equation or mother equation. If you put x in the mother equation, you get the corresponding values of y. Go through it again on your own, slowly, step by step. Okay? Then do it on your own. Number 3, get a similar question testing you to get the coordinates of the turning point. And number 2, distinguish. We have distinguished. I didn't fully do the coordinates of the turning points, but that is what you can just do within a second. Bye bye. See you.